Well, trying to hallucinate over there.
I got a good 3 hours of sleep. It was really good.
Oh. We're actually all in Travis's dream right now. Think about that for a minute. All right. Don't wake up, man. Come on. Shit. All right. I watched that too much Rick and Morty.
Oh, yes, I love that show.
Even yes.
Come on, Morty. Come on. Math is important, Morty.
Adult Swim needs to hurry up and approve season 4.
I don't know,
They
Rick.
improved like what? One 27.
All right, I'm sorry I started that.
Oh, thank
I
God.
still have never seen that show.
All right. While I've been back and forth, did anybody try either one of these?
Oh, yeah, I
You're like,
definitely have tried
I know you
that.
tried it.
I
and,
tried it. I didn't.
All right.
I tried tonight.
Okay, how do you do this when you get like a +5 and a +5Z and a +5Z top and bottom when you freaking double kill?
Which one are we looking at?
18.
18. Okay. All right, here we go.
I killed
Both
one.
18 and 21 have weird answers. So when I solve an equation, what are the situations? I could either get x equals 2 or something, which is normal, or I can get no solution, or I can get all real numbers.
What does that mean?
What do you mean?
How can that be a
So
solution?
let's recall. If I've got this equation,
Okay.
and I solve it, some of you guys might realize this doesn't depend on x. Do you guys see how the minute I wrote this, you noticed this does not depend on what x is. Isn't this just a true statement? No matter what the shit x is. Because what is this really a definition of? Distribution. Now, you don't have to go into a problem knowing that. Let's start to solve it like we always would, right?
Yes.
Let's start to solve it. So I distribute. I get my x's together, and I love you guys. You guys hate variables, but the minute they're about to die, you try to save them. I got you, x. Dead. Don't put x like he survived somehow, right? And then you get 2 equals 2, and then you stare at the paper, you're like, wow, math, thanks. 2 is 2, that's fantastic. But what this is, it's trying to tell you, now when I solve a normal problem and I get like x equals 6, that means that when this is true, then the equation is true. So when x is 6, then x plus 1 is 7. That's ground shifting. But now I can interpret this. When 2 equals 2, this equation is true. Well, what days is 2 not equal to 2? I mean, every third Wednesday. No, it's always true, right?
Yeah.
So this is an all real number situation. That's the solution to this equation.
So that's what you put for the answer?
Yep, all real numbers. Don't circle 2 equals 2. That's like, all right, you went into that knowing that before.
Okay.
The solution is all real numbers. Now, if I would have done this one thing, this is still related to these two, believe it or not. If I would have done one thing to this, if I would have made this 2x plus 3. Now, there ain't no damn way that would work. There's no x's that would work for it. 2 times x plus 1 should equal 2x plus 2. It can't be 2x plus 3. And again, if I start to solve this, right, distribute, subtract 2x, I get 2 equals 3, and then you really stare at the paper. Like, what the shit are you doing? 2 equals 3? No, again, how do I interpret? When 2 equals 3, then this is true. So this is never true. Right? Math don't have no mouth. This is the best way it can communicate with you. It's like, all right, dude, you did all that shit. When 2 is 3, you're fine. Oh, okay, I'm not fine. No solution. How are we doing so far?
So you gotta do the whole problem to realize that?
Yeah,
Aw.
pretty much.
Of course you do. What's wrong with that?
I did the whole problem 3 times because I couldn't figure out why I kept getting 0 equals 0.
All right, so you got to remember, I said this the other day. Do 2 lines have to always meet? No.
No.
They can either never meet, they're parallel, so there would be no solution, or they can lie right on top of each other, in which case there would be infinite number of solutions, specifically all the points on the line. The answer to a system of equations is where they meet. If they meet everywhere, then all the points, that's the answer. All right, so what's that going to look like in a problem like this? So I'll tell you, I'll give you this. 18 is no solution. 21 is infinite number solutions. It's what's called a dependent system of equations. Let's see. Which one? I'm going to do one of them. Which one do you want me to do?
For 21?
18.
18.
Okay.
Damn. What was your question about 21?
I was going to say how for 21, when I did it, the numbers I multiplied by to like kill the variables, in the long run, like my fourth and fifth solution that I got, they ended up canceling without me like having to multiply. Does that happen, you know?
That could happen, yeah. So 21, you should end up with 0 equals 0 somewhere, or something like that.
Yeah.
8 equals 8, or something like that.
Okay.
What that's trying to tell you is there's an infinite number of answers. What that means is, all right, let me see if you guys are cool with this. Does anybody know what a Rolodex is? Do you remember?
Yes.
It's sort of like me saying, how about 8-track tapes? You know, 8-track tapes.
Yeah.
I remember my mom listening to 8-track tapes. You know, like, oh shit, you know. Hello.
Sorry, is it that thing that Star-Lord uses?
Yes, no.
No,
He just
that's
uses
a-
cassette tape. Oh my god.
Player.
Let's.
Oh, no, no.
Aren't records those really
That's-
large
that's
CDs?
still
All
90s.
right, all right. That hurt me a little. All right. Rolodexes were these things they attached to a spine, and you had like a little index card you could write on, and then you could turn it and turn it and turn it. And so I could have 3. Remember, each equation with 3 variables is a plane, right? And the answer is where they meet. But can't 3 planes meet at a line? I don't know how to do this really well for you. I could have 3 planes. They have a picture in the book, page 654. I could have a plane, another plane, and another plane, and they all meet on this line. So that's one way I can have an infinite number of solutions, because how many points are on the line? Infinite number. All right, so, and notice this, if you look at number 21, let's see if you guys can do this. If you took, let me see how to say this to you. If you took the second equation minus the third equation, you get the first equation. Which, that's where that word dependent comes from. The first equation depends on the other 2. Is it really 3 pieces of information then? No. One of them I can get from the other 2. So I don't have a fully defined system. I don't have enough information to get the exact answer. That's why there's an infinite number of answers. Maybe.
So can I just do that from now on and not do the work and put 0 in?
That would be beautiful. If you notice that 2 equations combined somehow make the other equation, you don't have to do any work. You just say that's dependent. There's an infinite number of solutions. Beautiful. You got to be real careful about that, because you can make a mistake on that. So let's look at number 18. I think that was voted. So I got 4x plus y plus z. 17, is that right? X minus 3y plus 2z equals 8. Is that what it was? Negative 8. 5x y plus 3z equals 5. Now, watch one little thing, please, dear God. I'm about to say something a little weird. You never have to do what I'm about to do. Notice, what's 4x plus x? What's y minus 3y? Negative 2y. What's z plus 2z? What's 17 minus 8?
9.
Oh shit, that's why there's no solution here. If there's a 9 there, the answer would be dependent, an infinite number of solutions. All right, now, if you don't understand what the hell I just said, that's not bad. That's actually fine, because I'd rather you do the work, because you need practice for that anyway.
Question. If we were to do that on a problem and we realize, oh, it's going to be no solution, then we would have to
No, you just tell me what you did to look at it. I mean, to be honest, you do need the practice, but then not every problem is going to be dependent on it anyway, so you're going to get some practice. And I always said the more you understand, the less you should have to do. Does that make sense? In math, the more you understand, the less you should have to do. Because you should be able to get use some clever stuff and get somewhere quicker. Ain't nothing wrong with it as long as you explain to me what the shit you're doing. All right, so where would I start to solve this? Just forget everything I just said. We don't notice anything about this. We're just going to do it. How would I start?
Take the first one.
Yeah, which letter do you guys want to kill? Which letter?
I want to kill Y.
Yeah, why do you want to kill Y?
Because why?
Why not?
Why else? Why are you asking all those questions?
Because the numbers
Because that's my job.
will multiply out smaller.
Because Y is the only variable where it's positive and negative already. If I have to introduce negatives, I can make a mistake doing that really easy. You should be able to do it, but even I'm not going to do it. Though I'm really damn good at math, I'm still not going to do it because I'm a human. That's a place where I can make a real easy mistake. So I notice, I'm like, oh, here, I don't have to multiply by a negative. What do I multiply the first equation by to kill this one? I multiply the first equation by 3.
Oh.
Right? So I'm going to number my equations, and I'm going to tell myself and the dude that's grading this shit what I'm doing. Not that your work is shit, but just it is shit if you don't know what the hell you're doing. So what's 3 times the first row? 12x
Plus 1Y.
3y? 3z? The most common mistake is to forget to multiply that guy, but that's not allowed. You've got to multiply both sides. 51, I like. And if I add that to row 2, row 2 is x minus 3y plus 2z equals negative 8. What do I get? I get, again, just to make sure everybody's on track, pick a letter, kill it twice. I picked Y because it's the easiest one to kill, right? Sort of like survival of the fittest. Those guys are fit, he's weak, screw him, right? I'm going to kill that Y. I've only killed it once I combine these. Why have I killed it? Because the Y pieces cancel. So when I say kill, I mean cancel, right? Chapow. And here I get 13x
Plus 5.
plus 5z 40.
46.
I like it. Can you kill Y another way?
Of course.
What's the easy way to do it? I could take 2 and 3. That would suck so bad. Do you see it real quick? Do you see how it's sort of like an LCD? I'm not going to do this, but I have to multiply him by 2 and him by negative 3 to make them both 6 and negative 6 so they cancel. There's a much better way. How else going to kill Y?
1
times 2.
1 and 3. If I multiply 1 by 2, just like it did this by 3, it'll kill this piece. So you do that. Do that step. Go ahead. Kill Y between 1 and 3. There we are. We filled up a little bit better there. Edith. April's not here. Haley. Is it Haley or Holly? Haley? Joven. Ricardo. And anybody not get their test back yet? Okay. All right, guys, let me catch up to you. So if I take row 1 times 2, this will be 8x plus 2y plus 2z, 34. And just take row 3, pop, the way it is. And add those together. I'm going to kill y again. Oh. I get a little high and I can't off of these things. What do you get here?
13x.
13x 5z, 39. Now this is really freaky. I mean, this is where you guys are like, I must have made a mistake. But no, let it happen. Here's equation 4, right? Here's equation 5. Those are the best equations up on the board. Because they have the less unknown shit, right? How would I kill the x's, for example? I would multiply this by -1, right? Don't worry about what else happens. Let it happen. So if I take this and multiply by -1, it becomes -13x minus 5z. So what do you get? You get 0 equals -4. And that's, of course, where you lose belief. Math is bullshit. No, again, I really want you to understand this answer. Math is not telling you 0 is -4. It's saying, hey, everything you just did, this whole thing is cool if 0 can be -4. And you're like, no, that can't be, so there must be no solution. On number 21, you're going to get to a point where you get like 7 equals 7 or -2 equals -2, something that's always true, which means there's an infinite number of solutions. Yes?
So you can just go and take the inverse of like any of them?
Done.
No, I meant for the, I get everything there, but I was stuck with the 13, I didn't know if I could make the inverse. So I got plus 13, I got plus 5z and all that stuff.
Okay.
So,
And of course, I mean, the same way we would, if I wanted to kill the, where's a good example?
No, I did the exact same, I killed
Okay.
for y. Are we always supposed to make the inverse of one of the equations that we get? So we're supposed to make it a negative?
Whatever two equations you get, you try to kill one of the letters, either by substitution. And why do I not want to use substitution here?
Because you don't have.
I get a bunch of fractions, right? So elimination is better because it's already 13. I just got to multiply by negative to cancel. This one just happens to also cancel. It's not your fault. It's nothing wrong you did. Is that cool? You can have equations that you set up that will have no solution. And what that's trying, in the physical world, that could either mean, oh, you dreamt too big there, buddy. You got to pull something back. Because there's no way. Here's my goal. Let's set the equation up. No solution. Okay, we can't do that. Do you understand what I'm saying? That's math's way of saying, oh, that can't happen. Like, oh, shit. What do I do to make my lemonade stand make $5 billion next week? No solution. Oh, okay, shit, I'm sorry. I would have reined that back in. Yes?
So wait, for 21, when you said it like 0 would equal 0,
Yes.
that means like all real numbers?
Careful. The answer to a system of equations is a bunch of points. So to be specific, there would be a certain points on a certain line that the things meet up at. But we're not going to get that deep. We're just going to say there's an infinite number of solutions. Yeah, they're not all real numbers because what's the answer to a system equation? Not a number, a point. You don't say all real points because they are certain points. So just say infinite number of solutions if you get something that's always true. That's the opposite of no solution, right? No solution would be, the extreme opposite would be infinite number of solutions. Yeah. Bless you.
So what's the difference between all real numbers and infinite number of solutions?
All right, so all real numbers only works when you have an equation where the answer would normally be a number. So this one, the answer to this type of equation would normally be a number. Is there any specific number that makes this work? No, all real numbers make this work. Systems of equations have points as answers. It's the next level up. It's not just a single number, it's a collection of 2 or 3 numbers now. So you can't say all real numbers, that's not right. But we do know it's an infinite number of solutions for number 21. This one, there's no solution. So if you get a non-true statement somewhere, all your variables die, and your statement's not true, there's no solution. If your statement is true, if this would have said -4 equals -4, infinite number of solutions. Yes.
What if it would have been 0 equals 0 even though it's a true statement and there would be no solution?
No, 0 equals 0 is a true statement. All, no. Infinite number of solutions.
What was case where 0
Is this a true statement? No. No.
So how would
0 is never equal to negative 4.
How would an infinite number of solutions answer look like?
Negative 4 equals negative 4. 11 equals 11. 2 equals 2. Again, is this, how many real numbers are there? Infinite number. So another way to say this is an infinite number of solutions, but I could be more specific because I know it's all real numbers. I really want you, no, what? No, all right. Okay. Let's take this down to 2 dimensions, because 3 dimensions it's hard to visualize. Even though we live in a 3-dimensional world, and you draw me some 3D shit, not easily. So watch. 2x plus y equals 5. And 2x plus y equals 3. And I try to solve this system. Well, let me. There's going to be no solution for that, right?
Yeah.
But I want to do this one. This is where things get kind of silly. Let me do this. 4x plus 2y equals 10. There.
Okay.
If I solve this one, can you guys see how I'm going to get an infinite number of solutions? Because if I just multiply this by negative 2, I get 0 equals 0, which is a true statement, right? I can't say all real numbers because not all real numbers work in this equation, really. I mean, what's the answers to this equation? The points on this line. So where do these two things meet? All the points on this line. So I can say there's an infinite number of solutions, and I can be much more specific here. The solutions are all points on 2x plus y equals 5. All points on that line. Because if I graph that line and I graph this line, aren't they going to be on top of each other? Because they're the same stupid line. So where do the two lines meet specifically? They meet at every point that's on the line. Does it include this point? So saying like all real points or something doesn't make any sense because it's only the ones on that line. Same thing in 3 dimensions, just a little harder to picture, obviously. And that's why we don't get specific. We just say an infinite number of solutions. Okay. Higher level maths, you can actually get more specific. You can say all the numbers that are on, all the points on this line or something. We're not going to go that deep. Yeah. Okay. Maybe. When you start tacking on more and more variables, your answers have to get more complicated. Yeah. Yes?
So how would you solve that if it was like instead of 13x and like negative 13, if it was like 12x, and then like 5, like the 5z was like a 4z? Like how would you go and solve?
Oh well, that would just suck a little bit, but I mean, but still.
Would you have to like
Again,
go?
all right, now watch. Let me do this. So let's say I gave you this problem here. This is the actual beginning of the problem. Let's say, what was it? Yeah. And then again, 12x plus 4z equals. This is just going to be gross no matter what this shit I do. So too bad for everybody. Well, I can do something. Well, screw it. I'm not going to try to do that. All right. Now listen, this is complete, stay with me, everybody stay with me, right? What do you always look for when you're trying to solve a system of equations? When you're doing elimination, you try to see, can I just multiply 1 by 2 and it's the other one or something? That's fantastic. Can I do any of that shit here? How do you make 12 become 13? Times it by 13 over 12. I mean, that sucks. But so instead, you think about how do I make both of these? Now let's use these numbers because they're smaller. Yeah. How to make 5 and 4 become the same number? See how it's an LCD idea. How to make them become? What's the same number they can both become? 20. 20. So if I multiply the first one by 4, and I multiply the second one by -5.
Oh, yep.
So they end up, no Jesus. Eat Jesus. Multiply this by negative 5y so that they will end up canceling. That's all. They're not already opposite signs, are they? So I had multiple problems. I have to multiply by a negative, one of them by a negative, so they cancel. And I got to multiply so I get an LCD between the two of them. Right? So here I'm not going to do
Okay, but that's what you have to do if you're at that point.
You guys remember that? I mean, that's a part of this process. Well, here, let's do it. So you have 52x plus 20z equals 156, I think. Negative 60x minus 20z equals negative 25. Let's see what Jeff has wrought here. Negative 8x equals 121. 131. You could do it, buddy. There you go. And then that's not going to go in even less gross. But it's completely doable. Yeah. Totally doable. Okay. Curved a little bit. Anybody else not get their chest back or their twist corrections? Okay. All right. Anything else from homework stuff?
8.3 and 60.
Oh yeah, all right. I like it. The first two equations in that should be pretty simple, hopefully, right? I mean, you solve for y, get the equation in the line, graph it. So number 60 gives you 3 inequalities. This is section A3. This is where you got to graph the line, shade, graph the other line, shade. Now I've got a third sucker, right? And a fourth, to be honest. Oh boy. So let me focus on the part that's freaky. I'll give you one like it. If I said, let's see what's going to make better sense. It doesn't matter. Take a minute and do the first one. That should be simple. The second one, that's looking a little freaky. So that was nice. I already solved it for y for you. You just got to plot that line. What kind of line is it going to be? You got to shade on the correct side. So get that one done, and then I'll catch up to you. All right. What do we know about this line? Yeah, so the y-intercept is 0, 5. And from there you go
Down 1 over 1.
down 1 over 1, down 1 over 1, down 1 over 1. And what kind of line is it going to be?
Dotted or like that.
Dotted. I love it. Dotted, dashed. Totally your choice on which word to use. And then if I plug 0, 0 in, is 0 bigger than 5? No, or just greater than would be up from there, right? So that one's not too bad. So there's that. Let's see if blue is working. Is it working blue? Yeah, for the most part. Now how do I do this? Well, look, that one says y has to be less than or equal to 4. What's y equal to 4 look like as a line? Y equals.
Instead of 4 and make it vertically?
Nope. It's horizontal. You have that 50-50 chance on that. But think about it in a better way. If y equals 4, y can't change. Which way do I go if y changes? Up and down. If y can't change, I can only go left and right. So y equals a number is horizontal. X equals a number is vertical. So I'm going to have a line at 4. What kind of line? Solid. So here's 4. I'm going to have a solid line here. So it's got to be less than that, and it's got to be greater than 1. What kind of line am I going to have a 1?
Got it.
Dotted. So it's got to be in here.
That was a trick question.
No such thing as a trick question. It's just a question you didn't understand before now. Now you understand it? No worries. All right, so where's my answer going to be? In here. Is that okay? Remember we did the special, we did one yesterday like x greater than 2 or something, so it was a vertical line greater. Well, I can have y less than something and y greater than something, so that contains it in between here. And it's got to be greater than that line, so it's going to be in this area right there. That's the only place where all three are met.
So for 2, there's no way you can move it so it can just like the other one, or just like that?
Yeah, this one says, if you want to break it up, this one says y less or equal to 4 and y greater than 1. Y less than or equal to 4 and y greater than 1, that's in here. So what's the answer to the whole thing? In between there and above that line. So that part right there. So that point is not a solution to this, right? Because it's not in this area. So in the real world, if I was here, something bad's going to happen possibly. That's not the safe zone, right? Okay. So that's a lot like the one that's not the exact same as the one that was asked. But that should give you the idea of the one that was asked. Yeah. Okay. Anything else before we get back into matrices? Or actually start them. Okay.
Wait, I'm looking at 31. You don't have to do it, but for 9.1, why does it look like that?
Poor little thing.
It's only another level.
Yeah.
Is my book expensive?
No, what do you mean, why does it look like? They try to line the A's and the B's and the C's up for you. That's all. That's all. Yeah. So they're trying to be nice, and you're like, what are you doing? We're trying to be nice. Okay. Not sure why they're vaguely Scottish, but oh well. Okay. I'm trying to think about... Let's do this. Let me do this in this order. Before we get into matrices, let's talk about some basic stuff on the graphing calculator. If you need to borrow one, I need an ID with your name and face on it. I've learned from experience I can't be as trusting as I wanted to be. I'm only a teacher, so I can't keep buying new calculators as I lose them. So if you need to borrow one, anybody need to borrow one? Nobody wants to borrow one? You're all like, I'll just watch. Then come up here with I'm not going to walk around. Okay. Make sure it turns on. Sweet.
I'm not going to walk around.
Here you guys. Make sure it turns on. Don't go too far away. Ooh, you get some new ones. Watch out. So make sure it turns on. Make sure it turns on. Make sure it turns on. Oh, really? All right. Only you think that. You'll learn that later in life. Sure.
Okay.
Phone's even more important. Yeah. All right. Make sure it turns on. There's no like, there's no battery issue. Is that everybody cool? I haven't checked these batteries in a while. Good. Okay. I got one more. Are you gonna trade? Okay. All right. Let me turn this guy on here.
Got one more?
Yeah. Make sure it turns on. Yeah.
Oh, you guys going with it? Sorry.
Did you turn on?
We're going to 9.3 now?
We're doing some general calculator stuff.
Okay.
I'm also going to show you how to use the calculator to solve systems of equations for you.
With
Okay,
multiple X's and Y's.
X, Y, Z.
Yeah, perfect.
Beautiful.
That's what I
You can
want.
use it to check your work. If it does your work for you, it passes the class, goes on. You take it over.
Well,
Depends
some
on-
questions ask us to.
Yeah, totally. I could ask you to use a graph calculator because your answers are going to be gross.
That bonus question for the test, I didn't know how to do it on my calculator.
I'll show you that one too.
Okay.
That's why it was bonus. Aw,
Trick question.
bonus, I can do whatever the shit I want to. I just want you to know that. I can do whatever the shit I want to in bonus. Just unleash. And that's too bad. If you don't like it, too bad. I'm giving you a chance. Oh, I'm sorry. But at least the other two were totally doable.
Yeah, yeah.
But that one was just kind of like me seeing who knows how to do it or not. Okay. Let's do some basic stuff here. I love how I've set this up.
Oh,
So I
that's cool.
can't see you guys. Isn't that neato? All right. The true basics, just in case you've never used this before. Here's the on button right down there.
Perfect.
Shaboop. If you've never used a scientific calculator before, you're not used to being able to see the entire thing you're plugging in, right? I mean, it keeps track, you can see the whole damn thing. Let's all do this together. 7 minus 9 times 6 divided by 55. Enter. Let's make sure we all get that same answer. So this calculator understands order of operations, which means garbage in, garbage out. If you don't put it in correctly, it's not going to give you the answer you wanted. It's going to give you the answer of the thing you put in. You guys with me? So if I wanted to do this problem, I should probably turn you around, and I will in a minute. If I wanted to do this problem in the calculator,
Is that a 5.8?
yep, so 5.8. Right, if I wanted to do that in the graphing calculator, I cannot just plug it in like this. This is a mistake I'm about to make. Stop, you tripod craziness. There you go.